Good evening, ladies and gentlemen. For today's presentation, I'd like to talk a little bit about the way that polymers are formed in organic macromolecules. So, all organic macromolecules are made of individual pieces called monomers. Depending on which macromolecule it is, those monomers could be a variety of things. But regardless of which macromolecule it is, all of those monomers are assembled into larger structures called polymers. And you can see here on this diagram here, each one of these circles is meant to represent a monomer. And the group of circles together is meant to represent a polymer. Now, what's really fascinating about living systems is that all of the different macromolecules, lipids, carbohydrates, nucleic acids, and amino acids, are all assembled from their monomer pieces into polymers using the same chemical reaction, which goes by two names: dehydration synthesis or the condensation reaction. And basically what happens is you take one monomer right here, which has this hydrogen off the side, and you take another monomer with this hydroxyl off the side, and you combine these into a water. And where this hydrogen was, there's an open bond spot. And where this hydroxyl was, there's an open bond spot. And so what needs to happen is this water leaves and these two open bond spots connect, joining the monomers together. So we call this dehydration synthesis because synthesis means creation and dehydration means removing from water. So you're creating a bond by removing water. And we call it the condensation reaction because when condensation happens on like a cold glass of water, you see water from the atmosphere come out. And since water is coming out of this reaction, we refer to it as condensation. Now what I wanted to do was just take a look at some of these things. So this right here is polymerization of an amino acid chain. And so you can see right here, there's a hydroxyl group right there and a hydrogen. And instead, this water comes out and this connection is formed. Now, in amino acids, this connection is called a peptide bond. We'll get into that later when we focus on amino acids. But I just wanted you to see how it shows up there. Now, carbohydrates are current point of focus. Different carbohydrates have hydroxyl groups in different places. And so here you have a hydroxyl group and a hydrogen. And you'll notice here that there's a connection and an oxygen. And so here this water has come out. And this is actually how carbohydrates join. And here you have a disaccharide, but this is a disaccharide. And you could do this in just long chains for starch, or you can do this in a branching chain for glycogen. There's a lot of different ways that you can do this, but either way, you're going to have this connection here centered around an oxygen. Okay? And the result is a water coming out. Now in fats are a little more complex, but you can see right here, OH and H, OH and H, OH and H, and now those three pieces are connected to this bigger piece and three water molecules were made. And so that one right there is lipids. And down here you have nucleic acids. And you can see in nucleic acids, right here there is an OH, and right here there is a hydrogen, and these two things are going to leave, which gives us this water molecule right here, and also it joins these two together right there. Okay, so we're going to discuss each of these individual molecules at different times, and so that's real important. But I just wanted you to see how this similar reaction can occur in all of these different types of organic macromolecules. Now the flip side of this is, if I can combine these molecules by taking a water away from them, I also can separate these molecules by adding a water. So right here, if I take this water molecule and add it to this bond, I can separate it back into over here what amounts to my monomer, and over here what is a shorter polymer. And it's shorter because one piece has been taken off. Now, there is one thing that we haven't discussed, and that's, well, if water will cause this separation, isn't everything in living systems just water? And one of the things that's important here is this is not just water. This requires water and a special chemical called an enzyme. All right? And there's one enzyme that does this for the macromolecules. And up here, when we are removing this water, water doesn't just come out on its own. You need an enzyme to make this chemical reaction happen. And so that's part of living systems maintaining homeostasis. They create these enzymes so that they can polymerize and depolymerize organic macromolecules as they see fit. So, for instance, you might polymerize an organic macromolecule if you were replicating DNA, or if you were building a protein, okay? Those are just some real quick examples. You might depolymerize a molecule using hydrolysis if you were breaking down starch to eat, for energy. Or if you were breaking down fat for energy. Okay, so there's reasons you would do both, and there's also like recycling stuff that you're not using is why you might break it down. There's also like building carbohydrate chains in glycogen is why you would combine them. All right, so there's a lot going on in terms of why you would do it. But what's important for you to take away from this presentation is the processes that do this, and how interesting it is that they do this for every organic macromolecule. They all do the same basic reaction. All right, so that's polymerization.